When Charlie Brown sat in the classroom, we all remember what his teacher sounded like. Unfortunately, that rings true for a lot of learners who remember sitting in straight rows while the teacher lectured and they tuned out. So how can learning become more engaging, and how can students own their learning? Both in Vancouver and around the U.S., educators are increasingly using projects and problems in the classroom that require building, collaborating, researching, and testing. And that means less time passively listening and more time doing. I remember doing just that in Mr. Peterson's 6th grade class at Franklin Elementary. Mr. Peterson had us building all kinds of things. We made 3D topographical maps of Caribbean islands and outdoor survival kits for camp in the unlikely event we'd need them at Camp Trestle Glen. We even built model rockets and shot them into the sky on the last day of school. You know, I've forgotten most of what I learned in elementary school, but I remember Mr. Peterson because he made learning fun. Hello and welcome to Feedback. I'm Mark Ray. Today we're talking about project and problem-based learning. It's the idea that kids learn best when they have to make sense of problems by conducting research, testing theories, and seeking solutions, often as they're building or making things. For this reason, project and problem-based learning is sometimes referred to as the maker movement. One of the leading organizations for project-based learning is the Buck Institute. To them, project-based learning is about students gaining knowledge and skills by working for an extended period of time to investigate and respond to an engaging and complex question, problem, or challenge. But at Vancouver's iTech Prep, this idea has been built into the very fabric of the school. We had students there ask each other about what this means to them.
Usually for me, it's like hands-on work.
If I can see it and do it with my hands, then that's how I learn the best.
I like seeing it visually and having it in front of me.
Try and do something that I can make or build or just mess around with so that I can see how it works.
I guess if the teacher's really engaging, then I get a better concept of it in my mind.
The quality of the presentation is definitely affecting the quality of the learning.
We show the skills that we've gained from the teacher within like a certain subject of a project that they usually put us to do.
Project-based assignments to make sure that the students know what they've learned and actually use what they've learned.
Being able to not always just have to do the worksheets, but be able to create something with what you've learned and learn while you're creating.
It would probably be doing a lot of the projects.
The technology and the programs that they give us access to.
Maybe the projects. Some of the projects are a lot of fun.
Probably that I'm learning new concepts and that I'm going to be able to apply these when I get out into the real world.
There's always new and exciting things going on.
So that was great to hear from the kids. We have some adults with us too. From Skyview High School, could you introduce yourselves?
Nate Macon.
Luke Glassett.
Great. And you're both teachers, correct?
Yes.
Yep. Okay. And from iTech Prep, we also have two guests.
Cindy Hagan.
And Bill Dunlap.
Cindy, you're a teacher, and Bill, you're a parent and volunteer at iTech. Is that correct?
I try, yes.
Great. That's fantastic. So, adults, what did you hear from the students that stood out to you?
I think one of the things that stood out to me was the engagement of the students in the projects that they were doing.
Cool.
I very much liked one of the students specifically said something about getting his hands on something. I think you get your hands on it, you can really figure out how it works because it's not something in theory, it's not on a piece of paper, it's you can literally see whatever it is that you're talking about operating right in front of you. And I thought that was very astute, and that resonates with me.
I liked how one of the students said that she was using the skills that she was learning and applying those skills. And so she was able to see the benefit of learning those skills by applying them during the project.
Do you think that happens? I mean, does that happen in all classrooms where they can make those connections?
I think it's tough. I think you got to have a teacher who really owns that, because I think there's a certain level of like acceptable failure that occurs with projects. You got to have students that care and students that just dive in and that want that kind of experience. And then you have to have subject matter that I think can be creatively lent to a project.
Yeah, and I think also too with that you need to have teachers that care and teachers that are willing to put in the time and effort it takes to see a project through. And then some of the effort just in class and making sure that students are staying on task or engaged, in those that get lost in a project, how to redirect them as well.
So you, the three teachers here, do project-based learning in different ways in your classroom. So what does that look like in the classroom? Can you give an example or some lessons learned?
I teach subjects like Nate was just talking about that lend themselves to project-based learning. I do computer science and robotics, and so it's very easy to incorporate projects in those subject areas. In computer science this year, one of the big projects is students are going to interview people and find out what type of app would be helpful to them, and then they're going to design and build an app. So that's where they're able to apply those skills that they're learning, the basics of building an app and finding out what people need and how do I meet those needs.
Yeah, I think you have some subjects that really do lend themselves. I mean, in physics, for example, we can talk and do a lot of problems about trajectories, but towards the end of the year, we'll build something that actually launches a golf ball. But something that launches a golf ball to where they can say, hey, it's going to land within this 1 square foot, which is that's a pretty precision device then at that point. And it's not going to land 1 square foot away, it's going to land 40 feet to the left, in this one single square. And if it doesn't land in the square, it's going to land in the squares around it. I think you can really marry the idea of science and technical learning to the idea of creating a tangible product, and then how they build it is completely creative, and I think that's something that we really strive for. But I mean, I got to say hats off to the teachers who don't teach science, because I think that in terms of projecting there can be, I think that's where it truly gets creative, and that creativity is like what I desire in my classroom, because the answer that I would come up with 9 times out of 10 is nowhere near the answer that the students are capable of.
Yeah. So Luke, what about you?
So, yeah, and I don't teach a class that's traditionally project-based. I teach history classes, so world history, or right now our current world problems class that we have for our seniors. But what you were finding is that the more and more you try to align your classes around the Common Core standards, the more that you'll see that they're driven in that way. And so the focus is going to be on research-based projects, but also documents. And so getting, when we talk hands-on, often it's getting kids hands-on documents, but or the research-based projects. One of the things that I notice is that sometimes they're messy, and that's all right. And you can't always put clear parameters around it. And so right now, one of the projects my seniors are working on is they're looking at clothing companies and the sustainability behind those clothing companies and their social responsibility and their practices with their supply chain. And since this is a newer thing and different companies do different things, I couldn't just say, here's what I need you to have on this. I kind of had to open it up and say, let's research this together as a class. What can you find on this company? What can you find on that? And kind of work together collectively as a group.
Yeah. So Bill, you volunteer at iTech and are involved in some of the activities that students are doing. Can you pull up an example of something where those kids are really hands-on and doing some
When I get asked in, personally I'm a nuts and bolts guy. I don't bring an educated background like these guys do. All my education has been on the streets. So for my real job, I work as a fireman. So with that, I bring in I can't tell you why things work. I just know that they will. Mm-hmm. And I've had enough failures in my life to tell that this won't work or this will work. And when I come in and I teach a pulley system, these kids get to pull on a rope and see that the load, they can't move it. They can't move a 200-pound load. They're not picking up a 240 45-pound bald fireman with the load that they're trying to pull, you know? And then we go to a different pulley system or add a pulley or teach them where the pulleys go. And that's when it starts. You see these kids, all of a sudden you'll see a kid in the back that wasn't playing well with others, you know, he was sitting in the back and all of a sudden his head starts going, yeah, and then he moves up to the front and he'll answer the questions that I'm asking.
Yeah.
So
I'm hearing solving problems, asking authentic questions. I also heard messy. Someone mentioned messy, that it's kind of a messy thing. So let's talk a little bit about messy, because I've been to ITAC and seen some of the projects that they do, and it's a hot mess. And the kids are all in there, and they're showing like they were doing the Rube Goldberg activities. So what role does messy play in project-based learning?
Well, Bill used the word failure, and I think that understanding how to deal with failure, or even changing our concept of how we view that as just part of the process of learning, really plays into that. That sometimes when you're looking into something, you may not find your answer right away, and you may make a few mistakes, and you may have to go down a few wrong roads first before you get there. And I think that really plays to part of it. But ultimately, I think it really helps the retention for the students because they were part of that solution.
well, as far as the teachers here, I mean, you guys have been teachers long enough to know that you can learn as much from a bad teacher as you can from a good teacher. You can learn what you don't want to do. And I think that is, I don't want to say, I guess I shouldn't have used the word failure, but the word, that's where you learn, that's where that mistake will not be made again.
Yeah. Well, and I think it's a good word. And it's one that we're discussing a lot in education now. And I think that's a good thing.
Yeah, it's not success at any sacrifice. In fact, in many cases in all of my classes, like when I pose a problem, it's extremely open-ended, and I'm setting them up to make some wrong decisions.
Yeah.
Because those wrong decisions create a lasting memory. And if I'm lucky enough in my classroom to, within the circumstance of a project, have a kid create a memory that lasts 40 years, I mean, that's gold.
Yeah.
That's gold. Even if it's like, wait, that was the wrong one. If that's a 40-year memory, that's what we have to have in education. I mean, that's the gold standard. If I can create a memory that's beyond 40 years, a lifetime, is something that's entertaining. Of like, we got it wrong here, we got it wrong here. Ah, but it worked when we did this. That's what we want. And and then within the context of the 53-minute class period, like that's setting that up is setting up creating longer lasting memories. And so that's why I think that failure is something that like we all kind of have to confront, because like if the students fail, we share success and failure with those students. But as long as we keep moving forward and like progressing, like, hey, it's okay that you screwed up. That was your first time ever doing that.
Cindy, in your coding and your programming class in the robotics, there's kind of this process of trial and error.
Absolutely, yeah. I start every year talking about the quote from Honda, success is 99% failure, because you are going to make mistakes, but that's how you learn. And both robotics and computer science have debugging as one of their standards. And so you're going to find errors, and you have to figure out what they are and how to fix them. And like Nate was saying, those failures lead to retention. In computer science, they built a video game, and one of my students kept making the same mistake over and over, and at about the sixth time the same mistake, she got it. And every time from that point forward, anyone that needed help, she would be just like, check this. And she was able to help them just because it was there at that point. So
that's great. I'm thinking about failure, and one of the areas where failure is not an option is in terms of preparing students for college, career, and life. And there's a big emphasis on making sure that our graduates are ready to succeed after they leave our schools. And so I guess the question would be is how does project-based learning set them up for that success? What are you finding? I mean, what are you doing differently in your classes or in the projects that are taking place at ITAC that prepares them for that success?
Well, ideally, it's persistence. I mean, you gotta have, I mean, there's two sides to the coin. The teacher can do everything and set up the project and say, hey, all you gotta do is, tap it in. Or you can set an open-ended question and let the student flail around, figure it out, try to find different ways to solve the problem, whatever that problem is in whatever context. And hopefully, what they find is that they'll find something that works. And when they find something that works, they remember it, they retain it, and they understand that, okay, this problem can be like any problem. It doesn't matter what context it's in now. you're teaching that there's always going to be some sort of a valuable solution, and the persistence is what really matters.
Yeah, I think so too, and I agree with them 100%, and I would add, along with that, perseverance and hard work, because I think one of the things that if we want people to be successful in college and in the workforce, they need to be willing to work hard for something and not give up. And the more that we can continue to push them to do that, I think the more ready they'll be.
Well, we had an opportunity to talk to one of the business leaders here in Southwest Washington about some of the things that they are seeing and needing from today's graduates. And let's take a look at that.
Everything we do is basically video game based, one way or another. We do lots of things from theme park rides, but one of the big things that we're working on right now is a computer science curriculum for high schools. In high tech, we're always trying to solve big problems that a lot of people have never solved before. So it's not like there's a book that you can go to find the answer what you're looking for. So how to break things down into small pieces and then solve them is really important. So the reason I think project-based education is really important is because that's how we judge people during the interview process today. We want to know what they've done, what parts they've done and what they've actually worked on, the outcomes of what they've achieved. It's really important to us. A lot of people don't think about it, but collaboration skills, interpersonal communication, presentations, because we rarely do things by ourselves. So being able to do things in a group is really important, especially complicated things in a group, really important. I'm a really big fan of project-based learning because I feel like when I got out of college, I didn't have enough practical experience. In my first year, I felt really behind in trying to catch up with the team, and I learned a ton on the job by actually doing more hands-on things.
So it sounds to me like students need to act and work a little differently than perhaps what Bill and I had experienced when we graduated from Hudson's Bay in 1983. Sorry to date you there, but so things have kind of changed. So what are some of those skills? He talked about a few of those. What are some other ones that rise up that you think are really critical for those learners in the project-based classrooms?
I think collaboration is huge. Like Eric mentioned, you very rarely are doing things by yourself in a job placement of any type. And so being able to work collaboratively with other people and understanding that your contribution is important to the entire success of the project or whatever it is that you're doing.
What I kind of see is that kind of the same sort of thing that less and less of the kids that I see going through school are hitting the sports field. And that's used to be where the people learned the teamwork. And that's where you learn not everybody gets to be the quarterback, and that's okay. But that lineman's just as important. And now my kid is coming home and saying, I said, well, what are you doing on this project? And he'll tell me ABC, and some other kid's doing something more important. I said, does that bother you? And no, it's just part of the job. And my son has never been a sports kid, and that's kind of killed me, but he is as good a team player as any kid that I know on a team,
That's
on a
great.
sports team. Does that?
Yeah, that's great. That's fantastic.
I think too, we see the value of what companies are looking for in the project-based learning. So I know Cindy and Nate have both been involved in robotics. I've been involved in robotics at Skyview as well. And one of the things that we've seen is we've had kids leave Skyview that have been part of the robotics program and been chosen for internships at companies because they were part of the robotics program. And in one case, a guy was chosen over 2 college graduates because he had more hands-on experience being a part of robotics for 4 years than those 2 engineering graduates had.
Bill, Cindy, Nate, Luke, thank you so much for the time this afternoon. I really appreciate all you're doing with kids. It sounds like you guys are doing some fantastic things, both at Skyview and iTech, and look forward to seeing more opportunities in the future.
Thank you.
Thanks, Mark.
Thanks,
Thank
Mark.
you.
If you'd like to learn a little more about project-based learning, a good place to start is the Buck Institute, or BIE.org. It's an educational organization dedicated to project and problem-based learning. It's a great conversation. I really appreciate that feedback. Here's some ideas that jumped out to me. First, I heard that students value projects that include authentic work around real-world problems. I heard that project-based learning is messy, that it requires trial and error, and that failure is as important as success. Finally, I heard that in project-based learning, doing your own work is no longer enough. Call it teamwork or collaboration, the ability to effectively work with others is mission critical. But I don't think it's rocket science. It's the same thing Mr. Peterson did in 1976. Like Luke, Nate, and Cindy, he let kids solve, build, fail, and make their own meaning. VPS Superintendent Steve Webb puts it even more simply. Play more, make more, learn more. Until next time, I'm Mark Ray.